Now let's talk about how to implement normal distribution in R. I believe everybody should be very familiar to the concept of normal distribution, right? In the statistics classes or the introduction level of business analytics classes, we have learned this concept a lot of times. Why normal distribution is so important? Why we have to keep learning it? The reason is very simple. Normal distribution is built on top of a theorem called the central limit theorem. This theorem assumes that if the data sample size is large enough, no matter what probability distribution each object follows, the group of data will follow a normal distribution. This is very useful to contemporary business analytics because more and more big data sets are available to us. According to the central limit theorem, we can ignore the odd probability distribution each object in the dataset follows. We can assume that this data sample will follow a normal distribution. By doing this, we can simplify the probability calculation process. That's why we have to learn normal distribution in almost every analytical software. In R, it is very simple to implement normal distribution. Similar to binomial distribution, we have a dnorm and a pnorm. Usually we will use pnorm a lot, so let's talk about the pnorm function first. The purpose of pnorm is to set up a standard first, and then it will calculate a cumulative probability according to this standard. For instance, in the example on this slide, we assume that the number of products sold among our sales team follows a normal distribution. We find out the mean of this distribution is 15,000, and the standard deviation of this distribution is 4,500. Now we want to calculate what is the probability for us to reach a goal for next year. The goal is we would sell 16,500 products next year. Because this is only an expected goal, we are not sure how many products we will sell exactly for the next year. We could sell 16,499 products. We could sell 16,498 products next year. We have all these kind of possibilities. We need to consider all of them. So we need to calculate a cumulative probability for this standard 16,500 products. We need to use the pnorm function. And the way of using this function is listed in this example on this slide. Let's implement this function in the R software. The function name is pnorm, and then parentheses. We have three parameters. First, the value for the standard, which is 16,500, and then a comma. The second parameter is mean. Let's type in mean equal sign. The value for mean is 15,000, and then a comma. The third parameter is SD. SD represents standard deviation. The value for this parameter is 4,500. Let's press enter. According to the normal distribution, the probability for us to reach the goal of 16,500 products next year is 63%. Notice that the pnorm function will generate a left-hand value in a normal distribution, which is the shaded area as you can see on this slide. This is the probability for us to get a number of products sold that is less than or equal to the standard we set up in the pnorm function. If we want to calculate the probability that we sell more than 16,500 products next year, we have to use 1 minus the value from the pnorm function. That will be the right-hand value in this distribution. Corresponding to the pnorm function, there is the dnorm function. The purpose of dnorm is to calculate the probability of getting an exact value in a big data set. As I told everyone at the beginning of this lecture, we really don't use dnorm a lot in practice. The reason is, in a big data set, getting a probability of each value doesn't contribute a lot of knowledge to us. We would rather to know a probability of getting a range. For instance, the probability of getting the number product solved that is less than or equal to the standard. But if you are really curious about the probability of getting an exact value in a big data set, you can use the dnorm function. The way of using dnorm is very similar to pnorm. You will be surprised to see that numbers from a dnorm are very small. Why? Because in a big data set, we have too many options to choose. So the probability of choosing an exact value will be very small. That's why in practice, we use pnorm a lot, not dnorm. If you are curious about the probability of getting a value that follows standard normal distribution, you can ignore the mean parameter and the SD parameter in a dnorm function, as you can see in the first example on this slide. This means I assume that 2.75 follows a standard normal distribution. I want to calculate the probability of getting 2.75 in a standard normal distribution. Because it's a standard normal distribution, so when I use the dnorm function, I can ignore the mean parameter and the SD parameter. What is the difference between a standard normal distribution and a general normal distribution? In a standard normal distribution, the value for mean equals to 0 and the value for SD equals to 1. If you assume that the value follows a standard normal distribution, when you use the dnorm function, you can ignore the mean parameter and the SD parameter. This is how you use the normal distribution in R.